Okay, we'll get started. Please come in earlier, okay? Some of you just on the last minute to come in. Okay. So please come in earlier. Don't let people to wait for you, okay? That's number one. Any questions so far?
No.
No? Okay, first thing I would like to announce is we work on some project, some homework before, and then there's a project on this one, the calculator and the angle, Java Java calculator, okay? These two assignment actually is very good, okay? So some of you work on it, okay? Some of you doesn't work on it in the right way, but we will discuss this after class, okay? After class, we will discuss these two parts. And then what I would like to show you is that right here, I do give you a code.org link and section numbers. You can sign up these different sessions, especially this MACPI lab, okay? These are 3 AP computer science A lab, okay? And then in the past, these 3 labs are optional, so not every teacher will cover it, okay? And in the past, we sometimes teach it, sometimes we don't teach it, okay? But right now, actually, Code.org provide a self-study material. So what I suggest is that you need to sign up this one and study for yourself, okay? Hear me?
Yeah.
Harrison, do you hear me?
Yeah.
So if you hear me, you need to respond. How comes that I just hear Belinda's response? Pay attention to the class, okay? Is that okay?
Yeah.
Yeah.
So here a few sessions you can sign up. Number one here is the APCSA one. This one is actually the second half. The first half, the easy one, we don't put it there. We just put the second half in here. Okay, so you can do self-study if you want to self-study to work on more problem. Here has some material. But more important part is these 3 lab. These 3 lab usually in the past is optional, and some teacher cover it, some teacher don't. We do cover it before, but it take a lot of time. So this time we want you to work on it using the Code.org. Okay, these are new. Okay, these 3 lab are new. Code.org just offer this pretty new. So you actually right here, we do give you the link. You click on this one. It should lead you to a sign in page, okay? Or you go to your dashboard and add the session in, okay? You sign in and then add the session number in. So you'll get it, okay? You'll get it. And the session number, we actually show you, we actually pass the message right here. We actually pass the message right here, okay? Pass the message right here. So please work on it, okay? And then another thing is like we will work on the chapter 13 first, and we'll go back to chapter 12. Chapter 12, we still have the object class. We haven't finished yet, okay? And then beyond that, we may discuss some of the homework problems, a couple of the problems that not many students work out, right? Especially these 2 problems. Okay, these 2 Java calculator and Java angle problem. I would say no one actually get it done in the right way. Okay, I would say no one get it done in the right way. Also, there are students who work on the multiple choice, and we do give you second chance, right? So apparently, some students just copy the answer from the first answer and then fill it in. So they never study it again. That's not a good habit, okay? We do give you the response because we want you to study it and then understand what's going on. But some of the problem, because we are actually doing it for the first time, so some of the problem we do have typo. We may have some error, but there are just a couple of students who can respond to me. There are errors, but some of you never respond. But you just try to get your point, 100 point. Now, apparently, these are students who just want to get the job done. Okay, that's not good. That's actually not good. Kirsten, hear me?
Yeah.
You respond, that's good, okay? But
Okay.
some student did not give me the response. Do not tell me that something is wrong. That means they just copy the answer and then first time maybe get it 90, 85. And then second time, they just fill in all of the answer there. This is not the attitude to study computer science, okay? If you keep doing this, you will be out of computer science pretty soon. Okay? Hear me?
Okay. Yeah.
Yeah.
Okay. I just want you to make sure you understand it, okay? Okay, let's go back to chapter 13 and then we will finish chapter 13 and then go back to chapter 12 to finish up the remaining part. Okay, so chapter 13 is on array. I think everyone know array. So this portion should give us some time. We can go back to the chapter 12. Okay, so let's get started. Chapter 14 is the advanced array. So at that part, we will spend more time on the array processing part. Okay, that actually is more difficult part. Okay, and chapter 13 is easier. So let's actually go through the chapter 13 in a faster way. So chapter 13, array. Array is a group of data of the same type. Okay, so array is a collection of data that actually is of the same type. That's number one. Number two, array's size. Array's size, say you have n element. Array size you cannot change. You cannot change the size. You can create a new array. And then originally pointing to here, you can point into this new array. But the original one, you cannot do resize. No, you cannot. Okay, you cannot do resize. In C++, they do have regular array and resizable array. Okay, they do have that. They also have the vector that actually is similar to array list. But right here in Java, we only have array list and array. Okay, there's no resizable array. Or if you need a resizable array, you need to write a new class for yourself. Okay, but we don't have that. So this chapter will cover the declaration, instantiation, and initialization for array. So array is a data or a collection of data. And usually it's called homogeneous type. Okay, homogeneous means of the same type. You declare an integer, everything will be integer. Okay, so that need to be same type. It doesn't allow integer mixed with floating point, mixed with string. Okay. In Java's Python's list. Python list allow the mixing of the data type, but not in Java. Okay, Java's array we don't allow it. Okay, even Java's array list do not allow the mixed type. Okay. Okay, that's the first idea. Is that it must be homogeneous data collection. Okay, same type. So this chapter we'll talk about basic array type and then the basic operations, including finding maximum, minimum, sum, and difference, shift, rotation, shuffling. Okay, and then we will teach you reversal, transcopy, stepping, stacking, rounding index. Okay, rounding index, these different things. So let's get started from the basic one. Basic one, we do have, we would declare an array. Okay, so array is reference type. So reference type is storing the address. Okay, so you declare integer array A. Okay, then this one is a address holder. Okay, we talked about this before. This address holder will hold an address, but if you do not assign anything to it, it will be null. Means that you actually pointing to nowhere. Then you need to create a new array using new double. So this one is the array object. Array object get a new double 10. That's 10 element double type. And then you actually pointing to the reference to the array. Okay. So that's the mechanism. Okay, and then you use the index to access the array. Okay, so index you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you use the index so that you can calculate which element you will access in an easier way. Okay, in an easier way. Okay, these are the introduction for array. Okay, let's get started for some example. So first one, let's create array 1. Okay. Okay, you just declare array A and then you print it right away. Right here, it doesn't allow you to print, not because it's wrong, but because that this one is a local variable. So right here, this one, you complain that this value is not initialized. So if you move it outside, so let's move it outside to here, and then put it as a static. Because your static function can only access static data. Okay, static function can only access static data. So right here, if you put it right here, you will actually initialize it to null. Okay, in this case, you will initialize to null. And then if you print it, you will get a null. Okay, you get a null. Now you can do this. You can do A equals new integer 3. Okay, and you do system.out.print line A again. So this one, it will not print out the data. It will print out the data type and address. It will be array, integer, and address type. Okay, you will print out this. So if you want to print out the whole array's content, you need to use import java.util.array as this array as anything with s provides service routine. Okay, so this one provides service routine. So you were printing for system.out print line for A, you will not print out the array, you will actually need to do system print out this one, the toString A, then you convert the A to a string. That's a service routine for the array, and you will be able to print out the contents. Okay, any questions so far? So this
No.
one, it create a new array of 3 elements, and every element is initialized to 0, 0, 0. This is Java's property, okay? If you are in C++ or C language, you keep in the garbage, maybe 55AA, whatever garbage in there. It is the garbage that the previous runs the result, okay? So you need to initialize it to 0 by yourself. But Java virtual machine will clean up everything for you. Is that okay so far?
Yeah.
Okay, then that's the first one. Second one, if you do declare integer b equals new integer 3, that's okay. This type of the declaration, we call it C style or C double cross style array notation. Java allow it, but we do not recommend it. The reason we do not recommend it is that if you write it in this way, we know it is Java code. If you write this way, we know it is C code or C double plus code. So I usually use these to separate them. But by syntax, either way is okay. Either way is okay. They don't have problem. Okay, they don't have problem. But for myself, I prefer this way because then if I look at someone write in this way, I know it's actually Java notation. If someone write in this way, I actually call it the so-called C double plus or C language notation. Okay. Okay, you print out the data, you got B, okay, and then you can clean up, okay? So these are the way to create a new array. And then you can create a array. You can also do integer bracket C equal. You can put down the numbers that you want. So create the array by this string. Okay, by this string, and then you can print it out. Okay, this one is good. Now, sometimes you may have integer d, okay, equals new integer 4. But later you would like to assign a new array to it. So you say integer d equals. Can you do this? Can you do 4, 5, 6, 3? No, this is wrong. Okay, this is wrong. It doesn't allow this, okay? It doesn't allow this because this d, you don't know what size it is. This is size 4. Here is size changed to 3. You don't allow it. So what you need to do is that you need to tell it what kind of a data it is. So you do new integer array like that. Then that will be okay. So this one, let me keep it this way. Let me keep it this way. And then let me comment it out. This is wrong. Okay. And then d equals new integer. Okay. 4, 5, 6. Okay. This is correct. We also call it anonymous array or array with no name. This right-hand side is called anonymous array. array with no name. So when you do coding back, you do practice some of these before. Okay, but remember, you cannot, for the first time, if you the first time you assign this, that's fine. You have integer C, bracket C, you assign 1, 2, 3 to it right away, that's fine. If you declare a separate D, and then later you do D equals 1, 2, 3, that's not okay. You declare and then initialize it, instantiate it and initialize it, this is okay. But if you initialize it later, that's not okay. Any question?
No.
You have to do this way. You have to use an anonymous array. Okay. Later you will know that they are in Java, they are anonymous function, a number of class, a number of object, okay. Several of the anonymous stuff. And the anonymous function also called lambda expression. Okay, lambda expression. But right here, we are not discussing it, okay? Just let you know that data without name is called anonymous array, okay? So these are what we want to cover for the basic array. You need to know it. So basically, this one, we call it declaration. Okay, this one we call it declaration. When you do integer array A, you declare an array. Okay, this one we call declaration. When you say integer A equals new integer 4, this one called instantiation. Instantiation. So declaration means that this is A is a building, but where is the building? I don't know. So it's holding an address, but address is pointing to nowhere right now. And then instantiation means that, oh, I built a building of 4-story building, but inside the building, what's the content? No, it's null, it's nothing, it's actually 0. Okay. And later, if you do A0 equals 3, this is called initialization. You put some value to it, that's called initialization. Okay, so there's a search step. So you can also do A0 equals 4, A1 equals 3, A2 equals 7. This we call it initialization. Okay. Okay, this actually basic array. Okay, that's the basic array. So you can declare, no, not this one. You can declare double type array, you can declare integer type array, different type of array, okay? And then there are 3 steps: declaration, instantiation, and initialization, okay? Reference type, any reference type all have these 3 steps. And then primitive data type, there's no instantiation. It's actually declare and initialization only. Okay. So okay, so you declare an array integer array ARR equals new integer. Okay, so this ARR is a reference, but this ARR really is stored in a step. It is a local variable stored in stack, and then this object itself stored in the heap. Okay, it's stored in the heap. And then the array comes with a variable called the length. Okay, this one is the length of the array. Okay, default value integer type is 0, double type is 0.0, and then character type is this \u 0000. Boolean type is false. Okay, you don't need to clean it. Java, at least for Java, you don't need to clean it. But for C, C++, you require to clean them. Okay. Index value is the address that you use to access it. So let's assume that you have a element. You are starting from 0, 1, 2, 3, 4, 5, 6, 7. Okay. So why we start with 0? Why index don't start with 1? Anybody know?
No.
How about Jeremy? Do you know? Why array always the index starting from 0?
Oh wait, I think I know.
Hmm?
I think I know.
You know or no?
Oh, I
Yeah.
think I do.
You cannot hear me?
I think I do.
Yeah, then the answer. You just answer.
Because the array starts like with a pointer. Like it starts with a memory address from the first element, and then you have to add 0 to the first element to get the first value, and then add 1 to the pointer to get the next value and the memory address.
Yes, that's correct. That's because you want to have the address calculation. That's correct. But what is the advantage? You use 1, you also can calculate the address, but why use the 0? Not only the address calculation, okay, but also there's another reason. Jiang, do you know? There's another reason.
No.
Anybody know?
No.
This one's harder, okay? This one's harder because if you do assembly, they do have a address mode. They can jump by offsets. So what is offset? Offset means that you have a starting address. So right here, that's when this address is array 0's address. Then you add the offset, you directly jump to the location. So that actually using the offset calculation, there's one assembly instruction. You will be able to jump to there. It would be faster. Okay. Let's assume that actually you do have, let's see. Let's assume that you do have, let's assume that you have 0, 0, 0, A. Okay, this one for integer B. Okay, integer B holding this address. So B0 is this starting address. Okay, so the address of let's assume that you want to find an integer that is located at B2. So each one of these integer is 4 bytes. So this B2 would be this 0, 0, 0, A plus 4 times 2. Because each one is 4 bytes, it will be 4 times 2, you will get to the address here. Is that okay? Is that okay?
Yeah.
And that is what using an assembly code will be able to get it. Okay, using the plain code will get it. Okay, anyway, we will talk about it later. And each individual object is a variable. You can update it, get the data, no problem. Okay, I think you know it. You cannot do this. We talked about it already. Okay, only the first time, only you put in this, it's okay. If you assign new value to it, no, you have to put new double break it, just to tell the compiler what is the type of the data. Okay, that's what you need to do. And you can declare and assign the value by listing. You can declare a variable and then store value to it. Okay, I think this part is easy. So this part I think we will skip. Okay, it's easy. That should just go through it. I don't want to waste time. I think you know it. Okay. Okay, next one, because we are going to work on the numbers a lot. Okay, we are going to work on the numbers a lot. So we will basically teach you some basic operator. I think this is swap. We talked about it already, but I will actually emphasize one more time. So when you swap two variables, you do rotational swap. You have A equals 3, B equals 4. You want to swap, you pick up your A to temporary value. So you copy it to A to temporary value. And then second step, you assign B's value to A, so this one changed to 4. Third one, you assign temporary value back to B, so you assign to 3. So this one, we call it rotational swap. A rotation. Step 1, step 2, step 3. Okay, rotate the data. Rotational swap. Okay, second one, you can have buffer swap. Buffer swap, you have A equals 3, B equals 4. You want to swap A and B, so you buffer this one to C, buffer this one to D, and then you assign your D value back to A, so A become 4. You assign your C to B, then you become 3, so you swap. Okay, it's a buffer swap. Either way is okay, but usually people suggest rotational swap. Okay. Now we go into the processing of the array. I'm going to go through every single one of these. These are easy, but we will actually go through every single one of it using example. Okay, so I'm going to do array processing number 1. Okay, so this part I'm going to go a little bit faster. Okay, but all of these you need to remember. Okay, you need to remember them because in the coding practice you will need it. Okay, and this algorithm also will show up in the exams. So these are very basic algorithm. You must remember, you must memorize them, okay? Let's get started. First one, we want to create a array by assigning input values. Okay, let's do it. So we will get an array, and then we'll get array. Okay, let's do integer n. Okay, we'll get an array of n elements. Okay, so this one, let's do scanner. Input equals new scanner. Okay, and here we need to do import. Okay, and you need to get n numbers. So you do integer r equals 0, r less than n, r equals, okay. So this one, you do 0 to n minus 1. So when you type it, you will say system out f enter the percentage DTH number. Okay. So here you use I plus 1, right? First number, second number, you would need to use I plus 1, okay? And then right here, you will actually create a integer array data equals new integer array of n, okay? And then your data I will be equals input the next integer. And then when you finish, you return this data, okay? So that's the first array operation that you can use a function to generate array of n elements. Okay, so this one will get an array of 5 data. Now this one we would like to print the data out. Okay, so static void print array, and then you put your array here. Okay, and then you print each one of them. So here you can put the array name. So let's put it here. Okay. Okay, this one will print out the data one by one. Okay, so here let's print array. Oh, I forget the name. So name should be A array. Okay. So by doing this, you can customize your array name every time for the printing of the array. Okay. Any questions so far?
No.
You enter, but you need to print it. You print data. You put the data in here. I forget this one should be data length. Okay, I have in 0. Sorry. Okay, any questions so far?
No.
So these are this part, creating the array and then assigning value to it. And then you returning the array that you actually get it by the function. And also you print it. Okay, let's actually do another printing. Now this time, let's assume that your array have the data of 1, 2, 3. I want to print like Java's printing, Java's toString printing. I want to print it in this way. How can I print the array in this way? Okay. So the key problem right here is you only have 2 comma in the middle, right? So the way you print it, you have 2 ways to print it. First way to print is 1 comma 2 comma 3. That's one way you can print it. Second way you can print it is 1 comma 2 comma 3. Is that okay?
Yeah.
Yeah.
So whichever way is okay. Let's try the first way. Okay, let's try the first way. So let's print array 2. Let's use the first way. So you should have a string s equals empty string. No, you use this. Okay. And at the very end of this one, you do s plus equals the right-hand side of this, right? There's no problem. And then you will do system.out print line of the s. So you print of the s, the whole string you print out. Now, in the middle, how you actually add your 1 comma 2 comma 3 into there. That's what we want to do, right? So you have the left side bracket, right side bracket ready. Okay. You know, I teach you coding. Usually I teach you how to write it. Okay. So before you go into deal with the internal one, you actually finish these 2 first. Otherwise, later you will have more trouble. Okay. So let's either finish this. Then we do for integer I equals 0, I less than data length, and then I increase. Okay. So here, if I equals 0, then s plus equals a I is ready. Remember, this one is a plus equal. It is a plus equal. So here, do you need to do double quote plus AI? No, you don't need. Plus equal, you would automatically converting a integer to string. Is that okay?
Yeah.
Yeah.
But if you do s equals a plus b, this is integer, and then can you assign this? No, this cannot, because you are integer plus integer assigned to a string. That doesn't work. Only is plus equal that you can do it, okay? Only plus equal you can do it. So this one you add the 1 in already. So your 1, you already have this and this. Right, next one you are going to put in comma 2, comma 3, okay? So otherwise you would do this. Otherwise, as well plus equals, you should have a comma space plus I. That's it. You will be printing your string in this way. Because I don't want to confuse you with the Java array notation, so I use this, okay? I use this. So let's print this one. So you know that it actually is by our own printing data facility, okay? This one, remember, okay, AP tests this one many times. This 1 comma 2 comma things several times, okay? Okay, now let's print array 3. Print array 3, let's use 1 comma 2 comma and then 3. Okay, so this whole thing is pretty much similar, okay? So except that this one you don't detect for the I equals 0. you detect for I equals a the length minus 1. This is the last one, you will do this. Okay, the rest of them you do AI plus comma space. Is okay?
Yes.
This one is 1, comma, 2, comma, 3. So your function need to do AI plus comma space, AI plus comma space. Only the last one you do plus AI. Okay, these two systems must remember you have 1, comma, 2, comma, 3, and 1, comma, 2, comma, 3. These two either way work, but you need to remember both way. You can print out your array in the Java array to string format. These are very important. AP tests it almost every year. Okay. Any questions so far?
No.
Okay, I'm going to create another one. Let's call it array processing 1B. Okay, the part B for this array processing 1. Still array processing 1, but I'm going to create 1B because I'm going to do initialize it with random value now. Okay, random value. So let's do this one. So this one, let's call it, also name it as a get array. Okay, so public static integer array, get array of integer n. Okay, we're going to get unrandom numbers. So you do integer array a equals new integer n, and then you will return a. Okay, and then you do for integer I equals 0, I less than n, I increase. So this one, let's assume that you want to create an array of random number, but this number would be from start to end, but including, okay, here, important is including. So that's the integer from start to integer end. So from start to end, how many number? You need to calculate the span. So integer span equals end minus start plus 1. So for example, you from 3 to 5, you'll be 5 minus 3 plus 1. So total is 3 number. Okay? Any questions so far?
No.
Okay, so 3 number, and then you do this one. A's I number equals mass random times span. Okay, this whole thing need to be quantized. Right? You actually need to convert it to quantize. And then plus start. Is that okay? Hello, is that okay?
Yes.
That would be
Yeah.
a number from start to the end, including the end, okay? That would be what we want to have. So now let me go back to the array processing 1. So this one, let me call it array process 1A. Okay, so get array, I don't want to get it, I don't want to get by keyboard again, but this print array, I do want it. So let me get this 3 version of the print array. Okay, I sometimes may need it. So let me copy it. And then let me put it over here. So we have a get array, we also had a print array. Okay. Now let's go to try to so you get an integer array, get array, and then 10 numbers from 0 to 100. Okay, and then you do print array of the data. Okay, something wrong. Something wrong is the print. Oh, there's a string name. So far, okay.
Yeah.
It's randomly generated number. Now, let's change it to print array 2, okay? Because we know the print array will be working, but we want to use a simplified notation. Okay, so these are the random number. Now, we will work from here. We have a random number generated. Print array, we talk about it for 3 different times. That's okay. Summing all of the elements. Okay, let's start from here. So this one. Okay, these are easy, so I'm going to go through it quickly. Okay. So summing of the element, you get a sum, and you get an array A. Okay, here you can do integer s equals 0. Eventually, you will return s, and then for each integer b from A, s plus equal b. Okay, that's it. Now we'll get a sum. Oh, I forget to print it. So here, integer s equals sum of data system that out the green line of the printf sum course percentage b backslash n sum. Okay. Any questions so far?
No.
So these algorithms, you have to remember it, okay? You can do for integer I equals 0, okay? Those kind of algorithms is fine, but here we do for each element D in A, okay? We do that. Next one, finding the largest element, maximum, okay, maximum. So now next one, we're going to find maximum. So public static integer next one. Okay, first version, you want to find the maximum. There are 2 different versions that you can use. First one is you have the maximum, but initially you declare it as an integer that mean value. And then eventually you return n. So Harrison, what is this integer that mean value?
I guess the minimum value.
How much is it?
What do you mean?
What is the value of this integer that mean value?
Uh,
Who knows? Anybody know? Anybody know what is the value of this integer, the mean value? We talked about 2's complement before. So if you have a bit, positive part is 0 up to 2 to the power 7 minus 1. Negative would be from -1 to -2 to the power 7. So this one is the minimum. So now this one we change it to 32-bit. Then this value will go to 2 to the power 31 minus. This is the integer, the mean value. The very big negative value. Is that okay?
Yeah.
Why we pick this value? Belinda, why we pick this value?
Because we don't know the smallest value in the array.
Yeah, but why we pick this value?
So we can be sure that no number in the array will be smaller than that.
So it means that everyone can beat it, right? Every single data in the array will beat it or tie with it. Okay? Okay? So the first one is initially this m is 2 to the power 31 minus. So your first a 0, it will beat it, or it will be greater or equal to it, no matter what. So very easily you will replace it. Okay? So this one. So eventually, if you return integer the mean value, if the everything goes through, it still be integer. That means everything in the array is -2 to the power 31. Okay, that means it can only tell you that every element in the array is -2 to the power 31. Okay, does that make sense?
Yeah.
So maximum one of the data. Okay, so this one is to find the maximum data in the array. Any questions so far?
No.
So this maximum is 98. Okay, that's the first way you find it. Second way you can find it is don't use this one. You use A0, and here you can start from 1. Okay, this one's advantage is that you cut short. You actually have one less comparison need to do. Best thing about it is you may not have A0, you may have empty array. Then you are in trouble. You will have array out of bound problem. Is that okay?
Yeah.
So this one have to assume A is non-empty. Otherwise, you are in big trouble. Okay? So Kirsten, let me ask you a question. You may have learned C++ before or C language before. So in C language, what constant you use in here?
Uh, wait for the min value for integers.
Yeah,
Isn't there like a int min and like c limit?
yeah, in limits.
Yeah.
In C language is limits, but if you call it in from C double plus language, you put a C in front of it, okay? Okay, I just make sure you don't forget it, okay? You mix language, but you still need to keep knowing what's the difference between the language, okay?
Yeah.
That's the minimum thing you need to learn when you are computer science major students, okay?
Mm.
Okay, this one you get the same maximum. Minimum the same, okay, minimum the same. Then you know, just copy the maximum and change it, okay? So let's copy this min one and min two, max one and max two, let's copy. Okay, here we change max one to min one. But min one, you would use the largest numbers of max value. So here you would do less than, okay? This one, A0 the same. This one, min two, you just need to change the value here. That's it, okay? So then you can copy these two. You get the minimum value. Any questions so far?
No.
But all these you have to remember, okay? You have to remember. So here your maximum is 91, minimum 3, okay? I use this random number, 10 of them, just because I want to show you this maximum and minimum, okay? You will know. Okay, so that actually is okay. Now this one is large element, smallest index of the largest element. This one means that you may have 1, 2, 3, 7, 2, 4, 7, index 0, 1, 2, 3, 4, 5. So there are two maximum value. I would get this two index of this one. I don't get index of this one. Okay, so this one, if you want to do that, that's actually multiply the maximum one to get it, okay? So this one is actually changed from max one. So copy. So this one is called it maximum index. Okay, so this one you need to keep track of the maximum. You also need to keep track of the index. Okay, and then in here you update the maximum, you also update the index. So your index equals I. And eventually you don't return n, you return your index. Then you get the index, the first index, okay? So this, oh, here I have a mistake. This one should be minimum. Minimum. Then let's copy. So I don't demonstrate number two, okay? I don't demonstrate number two. I just demonstrate the first algorithm, okay? Any questions so far? So this one is 9, 9 is this one, okay? Any questions so far?
No.
But let's do it. If we do have 1, 2, 7, 3, 4, 7, If I want to get the index of this one, what should I do?
You need to go backwards.
No. Go backward may be okay, but not going backward. Go backward okay. But there's an easier way to change it. How about John? Do you know?
No.
How to find the second last one's index? Last maximum's index. You have two maximum, 7, 7. How do you find the last one's index?
Sort it and then get the sort it first.
Get the first we already told you, is it right here? But how to get the last one? How to get the last one? Anybody know?
Right, can you remove the first one and then just find the other
No,
maximum?
no, that's too much. You just use an equal sign. Because whenever you have maximum, you update it. You tie, you update it. You tie, you update it. So the last one, the tie will get stored. So just put an equal sign there. That will be the last index. Is that okay?
Yeah.
Hello? Okay, then there's another question. I'm not going to write it, okay? I'm not going to write it, but let me ask you a question. Now, if I have, say, 1, 3, 7, 4, 3, 7, 2, 8, 7, 2, 2, 7. And I want to find the third maximum. What should I do?
Wait, sorry, can you repeat that?
I have I'm sorry, this one cannot be 8. This one have to put it as a 5. I have 4 maximum in there. I want to find out the index of the third one. What can I do?
Can you like do a counter, and when the counter reaches 3, that's like the index?
When you counter reaches 3, you return, okay? You return the index when the counter reaches 3, okay? So I'm just giving you the idea. If the problem become that, you have to find an answer, okay? Don't just stay with the basic version. If you just stay with the basic version, you're not going to be able to handle the competitive problems, okay? You go into the competitive programming, you cannot just know the basic version, okay? That's why we actually go a little bit further into the more difficult problems, okay? So that one, okay. This one, okay. Smallest index of that's okay. Shuffling and shifting. Okay, let's finish these two up. Okay, shuffling. Shuffling means you have an array. That's a so it's 1, 2, 3, 4, 5. And you want to change the order for everyone randomly. Okay, you want to change the order randomly. Okay, so this one I'm going to give you the array version. There is another version in array list. Okay, we will wait until array list will do the shuffling there. Okay, so let's do shuffling in. Let's do shuffling. So for integer I equals 0, I less than 8 lines, I increase. Okay, now You do have a number, let's assume you are actually line up as 1, 2, 3, 4, 5. So what you would do is that let's pick this one and then shuffle with any one of them. Let's assume it's 4. Then you swap it. Second time you shuffle this one with any random one. Let's assume it's 3. You swap it. Third one you had a 3. You shuffle with 5. Let's say you swap it. So keep doing that until every single one at least be shuffled once. So you will have another one for integer j equals master random times eta length, and then quantize it. So this number j will be a random number between 0 and the eta length, but not including eta length. It's actually eta length minus 1. Is that okay? So this one is actually random index. You got the random index and the index I, and then you swap these two numbers. So let's do swapping. Integer 10 equals a I, and then a I equals a j value, and then a j value equals 10. Okay, and then right here you do return your 8. That's it. Okay. If you don't return, it's okay. The array still will be swapped. Okay, right here we just want to return with the array. Okay, so let's do swap, shuffle. So let's do shuffle data, and then print out the data one more time. Okay, let's print out the data one more time. Let's print out data one more time. Okay. So they will return the data, but that's not needed because here we use a swap. It will swap the content. Okay, it will swap the content in the A. So you don't need to worry about the content of the A. You already been swapped. Is that okay? This 20s happen to be in the same location, but it actually not always the case. Okay. Any questions so far?
No.
If you don't believe it shuffle well, then you can put a for loop. So that's for shuffle for 20 times. So for I equals 0, I less than 20, I increase. So shuffle for 20 times. Then it will be well shuffled. It will be shuffled a lot. There's another way using array list or using a shuffle zone and unshuffle zone. Okay, we won't cover it right now. Okay, it's actually too much for us right now. Okay, so let's just start right here. Okay, any questions so far?
No.
Next one, let's cover the shifting of the array. Shifting, you have shifting left and shifting right. Okay, let's do shifting left first. So let's assume you have 1, 2, 3, 4, 5. You want to shift left, it will be 2, 3, 4, 5. Let's assume you shift and you rotate to the left side. So eventually you will get this. Okay, so that's the goal. That's the goal you want to achieve is shift to the left. Okay, now let's erase it. So the first thing you would do is you back up your number 1 to 10. Then you shift from here to here, here to here, here to here, to here to here. And then eventually assign this to here. So it actually is a extended version of the rotational swap. Rotational swap, you have two numbers, backup, copy, backup. Here you backup, shift, 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 okay? So that's rotate left. Let's do rotate left, okay? or let's call it shift right. Shift can do without rotate. Without rotate, you will fill in a empty data into there. Okay, so let's do shift. And let's call it rotate. Okay. Okay. First thing you do is you pick up the A0. Last thing you will do is your A balance -1 will be assigned with the temp. Okay, that's your last statement. And then eventually you will return your A. Okay. And then in the middle, you actually shift one by one. So you do for integer I equals 1, I less than A length, I increase A's I -1 equals A's I. That's it. That's left shift. Okay. That's left shift. Any questions so far?
No.
Again, this one you can actually return, but it's not needed. Okay, you don't need to return it. You will actually rotate it. You return or not return, doesn't matter. So let's print array 2 again. All the algorithm we covered today, you must remember them. Okay, so this one you do shifting. Okay, now let's look at rotate right. So rotate right is the opposite operation of this rotate left. So you pick up the last one, and then at the end you actually assign back the first one. Okay, to the first one. So let's do us rotate right. Okay, this one is pick up A left -1. And then the middle part, let me delete it. Okay, I'll rewrite it. So at the end, A's 0 will be equals 10. Okay. And this one for integer I equals this one you will rotate right. So you have 1, 2, 3, 4, 5. This one pick up, you shift, and then assign back. Okay. So you start to shift from here. So it's from A balance -2, A greater equal 0, I decrease A's I plus 1 equals A's I's value. Is that okay?
Yeah.
And then we print it again. Okay. Rotate right. What happened to the name? Delete the extra E. So you rotate left and then rotate right again. So you actually go back to the original. Okay. Okay. So this is for this array processing 1. Okay. Let's go through the slices. Array processing tool, this portion, most of them use this. The only thing you would do is reverse of the array. Okay, reverse of the string and reverse of the array. We did it before. Okay, you can do swap of the symmetric location. You can do assignment of the last one to the new array. Okay, let's do this one. Okay, let's do this one with a rounding index. Okay, let's do this one with rounding index. Okay, you will return a new array. So integer array r equals new integer data length. Eventually, you will return this reverse array. Okay, then you are going to assign your A's value. Let's assume is 1, 2, 3, 4, 5. You are going to assign this one to 5, 4, 3, 2, 1. And you are going to assign it in this way. Okay. So let's have the rounding index p equals 0. For integer r equals equivalence minus 1, I greater equals 0, I decrease. So you do backward traversal. And then your r p plus plus would be equals a's i's value. That's it. Is that okay? I can do symmetric swap, but I don't want to do that. I just want to use this rounding index. So this is the power of rounding index. You do get this one to here, 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 this one to here. The index p increase to 1, 0 to 1 to 2 to 3 to 4 to 5. So every time you update it, your p will keep rounding. Okay. Any questions so far?
No.
For this one, you need to return. So you need to declare array data2 equals reverse data. Okay. So you got reversed. Okay. So what is the major difference between this shuffle and reverse? Shuffle, you have rotate right, rotate left. What is the major difference between this reverse and other one? Anybody notice? Harrison, do you notice?
That the second,
What is this one be unique?
it creates a new one from like,
And how much this is different from this?
what do you mean?
What do I mean? I mean by saying what is the difference? What do I mean? You have to figure out what do I mean. I am asking you.
I don't know.
Can you see the difference? That means you cannot. How about Kirsten? Can you see the difference?
It's just like moving the elements from the start to the end of the new array.
How about the shuffle?
The shuffle is modifying like the array that you pass it.
So this is the difference. Okay, this is the difference. So
Okay.
this one, the shuffling, you originally got data got changed. So this one is destructive array processing. Destructive means that I give you $100, but you change it for changes and give me $250 or $10 back to me. It's still $100, but that's not my original $100. Is that okay? That's destructive. This one is non-destructive. Non-destructive means that your A get in, you have this reverse function. Your A get in, when you finish A still A, but you create a new R, and the R is a new array you have. So A's content and R content has no relationship, and A's remain the same. That's called non-destructive array processing. This destructive is you do have the shuffling, your A get in, then your A will be changed. It's changed during the process. This is destructive. Does that make sense?
Yeah.
So in a way, can you write a function that actually doing non-destructive shuffling? Can you?
I think so.
How to do it?
Well, first you need to create a new array
And then?
of the same length, and then use a for loop,
And then?
and then you use the same random, but then you set.
You forget to mention one thing. The one thing that you forget to mention is that you do have a 1, 2, 3, 4, 5. You make a copy.
Okay.
And then you shuffle on this one. You shuffle this one so the original A is not changed. You copy it to B. Or you shuffle B and return B. Is that okay?
Yeah.
Then your original array is unchanged. So to design an array, whether it's destructive or non-destructive, you have to know it. You have to know it. Your function, your data get in, your side effect is that your original data will be changed. So shuffle, actually, for shuffle, you like it to be changed. But can you do reverse and destructive? Yes, then you use a swap. If you use a swap in a symmetric location, it will be destructive for reverse. Right here, I just show you using running index. Running index is non-destructive. Okay? Does that make sense?
Yeah.
And there's a difference, okay? There's a difference. Later you will know when you do more advanced programming, you know destructive. Sometimes you use destructive, sometimes you do non-destructive. You have to keep this in mind, okay? Don't make up a program and then you really cannot control it by yourself, okay? Okay, so this part, I think this chapter we would like to finish. The other things I think is out of date, not important. Okay, running index we teach you already. Next week we will teach you transcopy and other stuff. Okay. So we will have a short break. Let's come back on 9:35. We will be working on the object and the homework, okay? Maybe today is longer, okay? Maybe take longer time, okay? Come back on 9:35 with a break.
Wait, Mr. Chow, I have a question.
Yes, go ahead.
Do we have class on Monday?
Class on Monday for coding practice, yes. But if you have your own personal activity, you can go. It's optional for Monday coding practice, but I will open it for those one who want to do coding practice. I will be there. Okay, let me ask you the question. Who will be there on Monday? We have
I'll be there.
Monday. Who?
I'll be there.
Okay, up to you, okay? I'm not forcing you, up to you. It's actually, if any one of you will be there, I will be there, okay?
Okay.
Okay, so let's assume that we will be there, okay? Okay, any questions so far? No? No, let's have a break. Let's change the time. Let's come back on 37. Okay, we burn 2 minutes. Okay. Okay, number one, I actually post the call for you, okay? And then remember that this different lab, please sign up and work on it, okay? These are optional, but very essential, okay? You actually have to work on it by yourself, okay? And then one more thing is like, you may ask me a question like, okay, maybe your school or maybe UC Scout teach quite easy, okay? And then how comes that we teach not sometimes like not very difficult, so difficult, okay? Because we are actually want to teach you for competition, okay? So we need to cover a lot of details, okay? You can see that we actually try to cover a lot of details. And those details actually, we have to tell you. For example, some teacher may not tell you it's destructive or non-destructive, okay? But we do need to tell you the major difference, okay? So when you have a function, you have input, you may have an output. Another thing you need to know, not only the input and output for the function, another thing you need to know is the side effect. Side effect means the destructive or non-destructive. Will you destroy some data or not? That is a side effect, okay? Or some system parameter being changed. For example, sometimes the available mode available being changed, some system available being changed. Those kind of things, we call it side effect. That's more than just input and output. Usually a function is f of x equals y. You put some input into there, you get some output. But sometimes some hidden variable h got changed. That's side effect. You also need to know that, okay? Any question?
No.
No? Let's go back to chapter 12 for the object. This part actually, when I redesigned the course curriculum for 2026, okay? This actually I hesitate to put it in because they take away the inheritance. But eventually I decided to put them back because eventually all of you may participate in competitive programming. So you will need that anyway, okay? So we have to talk about it, okay? So first thing we would like to talk about is, last time we do talk about has a relationship, right? A class has some student array, right? That's actually has a relationship. There is another relationship called is a relationship. Okay, let's look at this is a relationship. And then starting from there, and then we'll talk about object class. Okay. And is a relationship is very important. Okay. So let me create a new project. Okay. So this one, let's call it chapter 12B. Okay. I'm sorry. Not 13B, 12B. in chapter 12. Okay, so let me call it chapter 2B. Okay, chapter 2B. So let's actually create a class. Let's create something like let's call it vehicle. Okay. So vehicle. So you have a string called type. And you have a integer that's called a value. Okay. You have these two data field. Okay. So your vehicle will be a string E and the integer V. Okay. So your type equals T, your value equals V. Okay, that's actually have a toString function. Okay, so this is the vehicle. So you do test V, okay, test the vehicle. I'm trying to make it easy, okay? Don't try to make it too complicated. So we learn array, right? We learn array. So now, can you do it? Can you do vehicle array V list equals new? Sorry, let's put in new vehicle, new vehicle, and then this vehicle can be a car, okay, $2,000 car. This one may be a boat, $10,000 boat, and then you for vehicle V from V. Okay, print out every vehicle in the vehicle list. Is that okay so far?
Yeah.
Harrison, are you okay so far?
Yeah.
Okay, make sure you understand. Okay, how about Stephen? Are you okay?
Yeah.
Now this is vehicle. The vehicle you do have car and you do have a boat, right? So let's actually look at this. You may have a new class. This one is called car. You have another kind of the vehicle that's called boat. Okay, so this is car. You may have a string, let's call it make. Okay, and then you do car, and then you need to have string make. No, let's actually do string type string value. And then, oh no, integer value. Okay, value is integer. And then string make. Okay. So car is one kind of the vehicle. So you do super type. Value. So here car is one kind of vehicle. So here you do extend your vehicle. So car will become one kind of vehicle. But here you do have this different, you do put these two values to the car class, to the vehicle class, I'm sorry, to the vehicle class variable. Okay? And then this make is a new variable in car. So you do assign this to here. So this is reach.make equals make. Okay? And the toString function that's actually do it here. Let's do property string toString. So car is one kind of vehicle. Okay, this I make them P4 variable, so child class will see it. Okay, I don't make it as a private. Okay, I don't make it a private. I don't want to make for trouble. So in this case, there's a car. So test vehicle. If right here I add another one. This one is new car. Is that okay? That's okay. You create vehicle, but car is one kind of vehicle. Car is one kind of vehicle. So we have a Honda car and put it into the vehicle array. Is that okay? That's actually okay. So this one, the vehicle become a collection of vehicle. It can be vehicle, it can be vehicle of car type, can be vehicle of boat, can also be a car of Honda make. Car of Honda make, of course, is a car. It's one kind of a car, but it just has one more data field called Honda. Is that okay? Let's put it in this way. Is that okay so far?
Yeah.
So this boat, let's actually look at boat. So this car boat is also one kind of the one kind of the vehicle, right? So let's copy. So right here, this one boat, that's also extends vehicle. So boat is also one kind of vehicle. Okay, so here we do change it to boat. So boat, it also have the make. So here we change it to boat. Okay, but boat usually Honda doesn't work on the boat. Let's actually change it to new boat. Okay, this one is boat. And then let's put in Yamaha. Okay. Yamaha is a vendor for boat, speedboat. Okay. So then let's look at it. You do have a vehicle array And then this vehicle array under there, they are car object. There's also a boat object. There's a one vehicle car type object. There's a one vehicle boat type object. So these are 4 different objects are in 3 different kind of classes, but they are all under vehicle. Then we can put an array of vehicle type to include everybody. This is called inheritance. Or sometimes we call it is a relationship, because car is one kind of vehicle. Boat is also one kind of vehicle. Is that okay? Hello?
Yeah, that's okay.
Yeah.
If you have question, you must ask, okay? Now, question is, then what is this to do with our object class? Okay, the reason why we talk about this is because we want to introduce the idea of object class, right? The idea of object class. Now, so you have the vehicle, you have the car, you have the boat, and the vehicle have a father. Father has a father, father has a father, her father, and has a father. So there is a grandpa. That's the reason these are called child class, grandchild class. Okay. And then there's a grandpa. The grandpa is called object. So everything under Java, everything that is a class under Java is a descendant of the object. Object is a grandpa type. Is that okay? Hello, is that okay?
Yeah.
That's why we call it object-oriented programming, because everything is an object. Okay? And everything has a grandpa is called object. Same thing for Python. Python is also everything is an object. So Python's grandpa is also object class. Is that okay?
Yeah.
So most of the OOP function, we can say that every class inherited from object class. If you do not say anything, say you create a vehicle, but you do not extend object, it means the vehicle extend object. So this one and this one is the same. These are the same. Okay? You write it or you don't write it. So basically, as long as you are a person, you are a descendant of the Adam and Eve. So Adam and Eve is the object class. Right? You know this, right? You actually, you know Bible, right? Eva. I don't know how to spell it. Everyone know it or no?
Yeah.
Yeah. If you know about Bible traces back to the origin of the people. It's these two people, okay, they create everyone, every human. So object is the same thing. Object is everything traced back to object. So that means that if you have some function, you will get it from the object class, and object class will give you all of the functions. So, okay, they are important classes that you need to know. There are a few important classes that you need to know. That is, okay, you do have an object class, then you have sortable class, string class, number class, math class, class, character class, Boolean class. Under the number class, you have double class, long class, integer. So you have new integer. You have integer, the mean value. You have integer, the max value. These are integer class. There's a double class. You have double, the plus double, right? These are the class. So all of these is under object. An object has 7 different functions. One function is called equals. That's very important. The other one is toString function. These two are very important. We mentioned about it. Okay, we mentioned why you need to rewrite it. If you don't rewrite the equal function, you will get double equal sign. If you don't rewrite it to string function, they'll give you the class name at the address. Remember that? So these two functions, you need to rewrite them because they are from the object class. So far, okay? Hello? So far,
Yeah.
okay? So we don't go into too much of these. The only thing that you need to know is this equal function, toString function. There are some other function as well, but not as important in AP level, okay? So that's that we want to cover this object, okay? Other than that, I think at this moment you can study for yourself. So for the equals, if you use double equal sign, you would check the edges, whether the two edges is the same. So you create a new object here and new object here. Even though the content is the same, but if the edge is different, the equal sign will be different. But if you do equals function, then depending on how equals defined, if they check the content, then these two may have a chance to be the same, okay? Okay, that's the equals function. So equality check, you may check same value or same edges, up to you, okay? So there are different checking of it. Okay, I think that's the object class we want to talk about. Next one, what I want to talk about is big integer and the big decimal. Okay. So big integer and big decimal is that big integer, when you have an integer, especially you go to user code competition, and then your 32-bit integer or 64-bit long is not enough. So you this one you up to 2 to the power 31 minus 1, right? That's your maximum that you can reach. But you may have a number that's bigger than that, or bigger than even than long. Long is 2 to the power 63 minus 1. You may have a number bigger than that, then you need to use a big integer. Is that okay? Hello?
Yeah.
That's when you do user code, you may need that. But this big integer is immutable. That you can create object and then after that you cannot change the data. Okay? You will create new data, but you cannot change the data. Now, one more thing is this big decimal. Big decimal is that when you do pi, you can do 3.141259256, whatever. Keep going. If you go like 200 digits, then your double may not be able to hold it. $200 may be okay. Maybe 2,100. Then your double cannot hold it. Then you need to use a big decimal. Okay, so these two was in AP, but they take them away. Okay, but in user code you will need them. Okay, so you will need them. So you need to know about these two things and the replica. Replicas in the chapter 3 we talked about it already. Okay, so here you do need to actually know about what is big decimal. Okay, now I just want to give you an idea of what is big decimal. Okay, so I'm going to give you an example. Now let's work on one example for big decimal. So this big decimal we want to work on is golden ratio. Okay, Fibonacci number. This number 1 plus 1 over 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 whatever to infinity number of the level. So what is this number equal to? Anybody know? Anybody know? Hello? Anybody know?
I'm not sure.
Anybody solved this problem before?
I saw it before, and I think it like went down to like a simple number.
Okay, so this one would need the big decimal. That's what I'm saying. Okay. So let's see. This number, you go to Google. It's called golden ratio. Fibonacci number golden ratio is similar. So the real number is, it actually is an irrational number. It is this number. 1 plus square root 5 over 2 would be equivalent to this one. Is that okay?
Yeah.
Okay. So what is golden ratio? Golden ratio is that when you have a paper, okay, you cut it here. This part is x, this part is 1 minus x. The whole thing is 1, right? So 1's ratio over x is equal to x over 1 minus x. So x squared is equal to 1 minus x. So x squared plus x minus 1 will be equal to 0. So x will be equal to minus 1 plus minus square root of 1 minus 1 plus 4 divided by 2, right? Something like that, okay? Did I 1 minus x squared? Okay, this one is actually this one would be x, okay? This one would be x. So x would be 1 minus actually x should be, that's assume is positive. It will be square root 5 minus 1 divided by 2. But the golden ratio is 1 over x. 1 over x is 1 over square root of 5 minus 1 divided by 2. So 2 move to here. So this one times square root of 5 plus 1. This is 1 square root of 5 plus 1. This one is 4. So 4 divided by this, you got square root of 5 plus 1 divided by 2. That would be the value that you have here. Is okay? Hello?
Yeah.
You see what I'm proving, right? So eventually, after the long division, you get this. Eventually, if you keep dividing this, you get this. Now, how to calculate this guy? Using program. Okay, I'm not going to teach you, but I'm going to give you the hint, and you do it. It's okay? And you try to use big decimal to solve it. So this one will be an edit project. If you finish, you can send email to me or post to my Facebook, okay? It's okay? Now
Yeah.
let's look at it. I'm going to give you the hint, okay? I don't want to write the program for you because I write a program, you will not study it, okay? That's the problem. So let's look at this one. You want to solve the problem of 1 over 1 over 1 plus 1 over plus this, right? You actually have many, okay? So let's assume that you have something called G naught. G0 equals 1. G1 equals 1 plus 1 over G naught. G2 equals 1 plus 1 over G1. G3 equal to 1 plus 1 over G2. Keep doing that until G200, G2000, G2 200,000. You will be approaching the value that you want to have. Knowing what I'm saying? Hello?
Yeah.
So Kirsten, what kind of program you need to write?
Recursive
Yes,
function.
this one by recursive, it will be very easy. Probably 5 lines of the code, you will solve it. Can you do it by for loop? Yes, you can do it by for loop. But how to do it, I would save it for you. You try to solve it, okay? Using the big decimal. Is that okay?
Yeah.
Everybody hear it? Because we are out of time. I don't have the time to write the program. Okay?
Yeah.
So that's something you can study. This is also related to the Fibonacci number, okay? We actually are run out of time, but let's see. We don't have the time to discuss the homework, but we do finish this object, okay? So I think homework maybe next time. But one thing is that please work on the chapter homework and also working on start to work on this MACPI project, okay? This one would help you to understand the homework we have right here. I'll cover this, okay? Next time, still remind me, we need to go over this problem. Java angle and Java calculator, okay? Any other question?
No.
No.
Okay, we have a lot of things to cover, okay? We cover this recursion just because that later you will need it, okay? Later you will need it. Okay, but that's it for today. And then let me have everybody can be dismissed. I'll talk to Tycho, okay? Hello, hear me?
Yeah.
Everybody else can be dismissed. Good night then. Bye bye.
Thank you.
Thank you.